to discuss the introductory part of the vectors. First of all, we will define what is a vector. A vector is a quantity which has a direction as well as a magnitude. Magnitude means a value. So now let's see how to draw a vector. Suppose the beginning point is A, the end point is A, beginning point is O. The vector is denoted by this arrow, and we typically write this OA. Now you can have another vector which is like this. You can call it PQ, and PQ vector is parallel with OA vector, and the direction wise they are the same. That's what I'm saying, parallel, but magnitude wise. So how do we denote the magnitude of vector? So PQ magnitude is defined by PQ mod, and that is not equal to OA modulus. So magnitude of OA is not equal to magnitude of PQ. Obviously, from the picture you can say that PQ magnitude is less than OA magnitude. Now based on that knowledge, we can understand how the vectors are acting parallelly. Suppose this is your OA vector and the PQ is parallel. So PQ vector is parallel to that. So now by looking at this, you can write OA vector is equal to K times PQ vector. Now here K is greater than 1. Why? Because obviously PQ is less than OA. Now if you write OA and you put K1 over here is equal to PQ, then obviously K1 is less than 1. So we should be able to play with those numbers. Now this is how we work with parallel vectors. Now we will try to understand vector addition. So if you have a vector OA and PQ in the same direction, right? So we have OA plus PQ, and the resultant vector is OQ. So that can be drawn like this. So this is O, this is Q, and this is OQ vector. Now this will tell you that the magnitude of the OA vector plus the magnitude of the PQ vector should be equal to OQ magnitude. So that is the understanding we should have. Now subtraction, or the minus negative vector. In vectors, if you define your vector as this, that way, so you can change the direction. O is here. You can change the direction and you can say this is minus OA vector. So always you can change the direction and you can represent that as a minus value. Now for example, if you have a vector OA and then I'm going to minus another vector PQ, which is like this direction. So this can be represented in this way. So OA vector, and then you can change this minus sign to positive, and at the same time you can change the direction of the PQ vector. So that would be a vector O, let's say OL, this way, OL vector. So what we know from here, that OA vector, magnitude of that should be greater than the OL resultant vector because of that minus. So this is how we play with the vectors. Now, if we have a few arbitrary vectors like this, one vector is V, the other vector is W, and then there is another vector goes in that way, you can call it R. So this is a vector triangle. So you can write, so this is a starting point O, I can say AB. So you can write OA vector plus AB vector is equal to OB vector. So from the figure you can see that if someone is trying to walk on this path, like from O to A, so he can go from O to A, you can see the arrow, and then A to B, eventually it seems that he walk from O to B. So this is the addition theory. So OA would be V vector plus AB would be R vector and OB would be W vector, and it's going to be very easy. Now if we have a few other vectors like this, starting from O, A, B, C, we have few vectors over here. So I can say this is A vector, and this is B vector, and this is C vector, and this is R vector. So using the addition rule, you can say that OA vector plus AB vector plus BC vector is equal to OC vector. So one can write A vector plus B vector plus C vector is equal to resultant vector R. So this is how we find the resultant vector. Now let's talk about how to do the vector resolution. So what is vector resolution? So simply we can say this is a representation of a vector by two perpendicular vectors. So now let's talk about how it works. Suppose you have a vector like this, call it V, starting point is this O, so this is B. Now the angle with positive x direction would be theta. This we can represent by two perpendicular vectors like this. This is the origin, two perpendicular vectors, this is 90, and the horizontal vector is V cosine theta. So remember, towards the angle it would be cosine. So the other one would be V sine theta. Now, what would be the proof? So there is a very simple proof for this one. Suppose you have V cos theta here and V sine theta. Okay. So now what would be my resultant? The resultant would be this, the diagonal. That would be R. This is your. Now we know that this V sine theta vector is can be parallelly transformed, so that this would be V sine theta. Now, and I would say this is P point and Q point. So from OPQ, right angle triangle, one can use the Pythagoras theorem, so that R squared, I'm taking the magnitude of the R resultant vector, R squared is equal to v cos theta the whole thing squared plus v sin theta the whole thing squared. So that will tell us that v squared is a common term, so you take v squared out. So then from here you get cos squared theta, and then you get sin squared theta from the other one. Now we know that there is identity, trigonometric identity, that cos squared theta plus sin squared theta is equal to 1. So from there you can say r is equal to v. So we proved it. Okay, so this is the trig identity. There are many trig identities, and this is one of the important and most fundamental trig identity. Cos squared theta plus sin squared theta is equal to 1. So this is the identity that we used. Now, for example, if I want to resolve this force, and this is the angle given theta, so if I need to resolve it, I'm going to resolve in this way: two perpendicular vectors, and towards the angle that would be f cosine theta. So this is what we need to know. The other one is going to be sin theta. Okay, so this is very important in many areas.